Okay, I'm not too sure how this video is going to go, but let's see how it goes. So the one reason I'm not too sure how it's going to go is my arm is just not that happy, but it is improving. So I probably should not do anything tonight, and just let it keep improving. And this might knock it back, but I'm going to try and avoid using my right arm as much as possible. So anyway, this is not actually the Sega Megadrive Genesis controller that I showed last time I did a video about the Megadrive controller. This is actually from another Megadrive clone thing. This is actually kind of interesting, this one. It has the same kind of plug, but it doesn't appear to work the way a proper Megadrive controller does, whereas the first clone that I tried does in fact appear to function the same way. The only problem is I tried building a tester for the Megadrive clone controller that does act like a Megadrive controller with an Arduino, which is actually sitting over here. So where I put it? It doesn't look very exciting at the moment. That's not it. Yeah, that's all it is at the moment. So I just plugged it all in and then printed things out to the serial output. But it seemed to actually, I made a mistake and I miswired it. And I think I might have broken the controller. So I thought, well, I don't want to break another one because I've only got another spare one. Maybe I should do it the other way around first. So I thought, well, maybe I'll try and build a controller. Not exactly like this, just with little buttons and stuff. But that would be the idea. And then I can test it, my tester on my built one, and if I break that, well, that's fine, and I can sort of test it a bit easier. Is that the right word? I don't know. Anyway, the point was, so how does it work on the inside? And it's very handy because, let's find the page. It just on the inside of the Megadrive controller or Genesis controller is, in fact, I believe, so what I found on the internet, and this matches up with the kind of input and output. I think I've gone and misplaced my piece of paper. That's what I was supposed to have. I was supposed to have my diagram of output, how the Megadrive controller actually works, and compare it with this picture here. But anyway, this is the 74HC157. In this case of the Megadrive controller, it's the HC version, so it's the CMOS version that acts like a TTL chip. So it's the 74, it's like the TTL series, but sometimes they are actually CMOS things. And so, well, you could build one if you just wire the buttons up cleverly to this thing here. So this basically, I can sort of talk about what it does, is you have these inputs, input A0 and B0, input A1 and B1, input A2 and B2, input A3 and B3. And for each set of inputs, so there's two inputs, A and B, and there's also an output. So there's output 0, output 1, output 2, output 3. And basically, if select is low, then you get input A coming through on the output, and if select is high, you get input B coming through on the output. I believe that's true. So low, where have we got this? Select being low, you get A's. You get the A's. If you get select high, you get the B outputs, and that's basically what happens when you use the selector line on the controller. You're just basically sending through and selecting one of these two outputs, and that's how you and so half the buttons are wired up in some way to some of the inputs and half of them are wired up to the other one. Some of them are probably just bypassing it altogether, like I think up and left and right, was it, or up and down are the same no matter what select is, so they're probably just wired straight across. We can come to that later. The big problem for tonight, let's see if this is actually in the picture. It's not actually in the picture, is it? There's a monitor in the way. I can't actually get this book all the way through. I think you can read it. You can read it. Okay, anyway, the point is, I don't actually have a 74HC157. I did in fact order some, and they have in fact, according to the email I got, arrived in the country and will probably turn up on Tuesday. But I don't have them today. So I thought it would be fun to try and build, before I build anything else, to build one of these ICs out of other ICs. And it's interesting, I think it's a good sort of exercise because it can kind of help, hold on, I'm just getting a piece of paper, understand logic circuits and how you might build logic circuits. So we've gone through like NAND gates and some gates at some point. So things saying this and that, or this or that. Boolean logic is what it's normally called. So I'm dropping everything on the floor at the moment. But I'm going to present this little diagram here. And this is going to be how we can understand the select logic in terms of Boolean logic. So it might not seem obvious at first because you're saying, well, if I select this, then I want these outputs, and if I select that, I want those outputs. And if you haven't done much Boolean logic stuff, then it might seem hard to see how that can be translated into ands and ors and nots and things like this. But hopefully this will kind of explain it. So here I've used zeros and ones because deep down I'm a computer scientist and I think in zeros and ones. But really 0 means low voltage and H means high voltage going into your inputs. So I've just put an L and H there and I put it over there. But from now on I'm just going to say 0 and 1 because I'm just used to saying 0 and 1 and I think it looks better on the page. So here we've got, these are all the various combinations of just one input pair, or two, there's an input pair and there's an output pair, and then there's a select pin. And so these are basically all the options. So you've got select being low, select being high, or 1. So if you have select, so this basically is one combination here. This is the case, you've got select being low or 0, A being 0, B being 0, and the output therefore is going to be 0 because the output, if select is low, it's going to be whatever is in here. So I colored this in kind of blue faintly, and you should see that they match up over there. So for all of these combinations, this is me basically just counting in binary roughly. But there's all 16, wait, is there 16? There's not 16 combinations here. How come I haven't got 16 combinations? I feel like I've done something super wrong. Because there should be 16 different combinations, shouldn't there? So, there's only 1, 2, 3, 4, 5, 6, 7, 8. Oh, my brain is all having a freeze at the moment. Why is there not 16 different combinations? I do have 1, 1, 1, and I do have 0, 0, 0, and I have 1 there. I feel like, no, we've got that one. Oh, no, that's right, of course. I shouldn't, sorry, my brain is all completely confused as to why I wouldn't see all 16 combinations, because there's only 8 combinations that are kind of valid, right? So you wouldn't get the combination 0, 0, 0, 1, because that's not a valid combination. So the point is, so these are all the valid combinations. So 0, 0, well, things that were going to happen. So the thing that comes out the end is this. So that's right. So there's 3 different inputs. So there's 8 different combinations for 3 inputs, and they all have a particular specified deterministic output. Made it way too complicated. Point being, when this is 0, basically the output will be whatever is in A, and when this is 1, the output will be whatever is B, which is like, so they're kind of matched up in colors. So it doesn't actually matter if this is 0, it doesn't matter what B is, and if this is 1, it doesn't matter what A is. Hopefully it should make sense. So if this is 1 and that is 0, the output is 0. It doesn't matter if the output, if A was 0 or 1, you still get 0 on the output. So this should that's the kind of like writing down the different combinations and what they all end up being. The next step is perhaps to write it out in words. So, sorry for the terrible handwriting. This is where it starts to get a bit weird. It's because I've been trying to write with my left hand. So this is mostly written in my left hand. In fact, it's all written in my left hand. And I'm better at writing in my left hand than this. It's just that when you just jump straight into it. And I'm right-handed, so I have to point that out. It might not make any sense if you thought I was left-handed. I can write better than this with my left hand. I'm getting better, but I'm not used to writing with felt tip pens or on a desk. So anyway, these are the relationships. So basically, if the select equals 0, in this case, you can write this as select with a bar across it, which means not select. If select is not, if select is 0 and A is 1, then the output is 1. So where did I put this thing here? So first part of the relationship. So select is 0 and if A is 1, then the output is 1. So in all other cases, it's going to be 0. And then, maybe I should have already gone with the then thing. Or if, sorry, this little bit here is just me writing that bit out. So I wanted to kind of like write it in a particular form. But we'll come back to it. So you can ignore that little line there. We'll just put a pencil through it, and we'll come back to it in a second. So if this is true, or if select equals 1 and B equals 1, then the output is 1. So you also see that in the same thing here. So select is 1, and if B is 1, the output is 1. And these are the relationships that state when the output is 1. In all other cases, it's going to be 0. So I shouldn't have said then, because then's a different relationship in Boolean logic that is kind of a bit trickier. But it doesn't really matter. We'll just go straight to this picture here. So I don't think I have to explain this. I thought, oh, well, how am I going to explain this? It just seems like natural and makes sense to me, but it's hard to actually, like, I'm feeling if you've never done this before, this is not going to make a lot of sense. So hopefully this little picture might make a bit more sense. So this is like done pictorially. So before I was writing it, so basically I've written the output is determined by this equation here, but this is like a Boolean equation. So in a Boolean equation, when you sort of like look like you're multiplying things together, because you put them together like the terms together like this, that just means and the plus means or. So and then the line above it means not. So this is not select and A, or select and B. And I'm going to kind of quickly explain that to see why that makes sense. So not select, so if select is 0, then not select is 1. So we're inverting it. And A, right, is only true when A is 1. So if that, this is going to be the trickiest part, I think. So this part here is saying if we have, this will be evaluate to 1 only if S is 0 and A is 1. So that's the only way that this becomes 1, because if S is 0, then not of S is 1. And if A is 1, and so not of S and A is only going to be 1 as a result if both A and not of S are also both 1. So that's what and means. So and means both things have to be 1 or true or high in order for that to evaluate to being high. Otherwise everything else is 0 or low. Same thing here. In this case you've got if S and B, they evaluate to 1, otherwise they evaluate to 0. So that's like S and B, those give you the 1s. And this is or, so if not S and A, or not S and B, which basically covers all the combinations on here that give you 1 on the output. And so that will give you the output when any of these things aren't true. So if S is high but B is low, and in order for this to be true, so both of these things have to be false, because this is an or. So or means if one thing is true or the other thing is true or high or 1, then it evaluates to 1. But if both of them are false, then it evaluates to false or low or 0. I'm going to actually quit with saying about that. We're never going to finish this video otherwise. But this will be this kind of like logic diagram if you're going to draw it pictorially. This is going to be the last part, because this is important, because you'll see when you look up ICs, and this is one of the ICs we're going to use here. I've knocked the camera again, I could have stopped doing that. And so they draw it like this, right? So this is the AND gate. We're going to be using this IC, the 7408. Not the ones I wanted, because I picked them out and then I've gone and lost them, but I've got some more, so it's okay. And so this one here has these little pictures, like in the picture form. So I thought it'd be good to draw it out as a picture. So this is how you draw an AND gate. I just sort of think of it like a Pac-Man or something. I don't know. The reason I remember what an OR is, it's got the curved bit at the bottom, and I imagine that there's an O here, O for OR, and it's fitting in and pushing up against that one. So here's the select line. It's coming into here, it's being inverted and going into this AND thing here, and the A line is coming into here. So if A and the inverted S are both 1, then you're going to get a high voltage coming out here, and this is the OR gate. And the same thing here, select is going into here but not being inverted in this case, and it's being ANDed with B, and if they're both 1 or high or true, then you're going to come through here and you're going to get a 1 going into the OR gate. And if either of these two lines are high, then we are going to get high on the output. But if both of these things are false, we're going to get a 0 or a low on the output. So that's the pictorial view. So what ICs are we going to use? Well, we're all going to use this. We're going to use the 74 series for the whole thing. So I could have used my friend the 4049 from previous videos, but we're going to use an IC which is essentially exactly the same as this one here. It's a 74HC157, which is an inverter, and I think it pretty much has the same pin out as a 4049, or at least it has the same as a 4069, which I'm assuming is the same as the 4049, but I've forgotten. Oh, the 4049 is slightly bigger, isn't it? That's right, it's got the 2 unused pins. So anyway, that will be a new IC, and the AND gate is done by the 74HC in my case, 08, which is this one here. So we've got those ones. So we're going to need quite a few of these if we're going to do 4 of them in the end. So this is going to be repeated 4 times in the final thing. I think for tonight we're just going to do 1. And then the last thing is the OR gate, and the OR gate I'm only going to need 1, and this is this one here. I hope it's this one here. Just going to double check. This is the 74HC 032, which is the OR gate version. So we'll have a look. That's what the AND gate looks like. The OR gate looks pretty much exactly the same. There you go, it's on the next page. So that looks exactly the same as that, except the gates are different, but they're laid out the same way. So that's nice of them to do. And we don't actually, I don't actually have a pinout. This book doesn't actually have the 74 HC14 in it, but it does have the 4069, which I'm pretty sure has exactly the same internal structure as the 74HC14. So that will be fine. So we've got 10 minutes. I don't know if I should just start or a new video, or yeah, we'll do that. So that was the basic idea, and I'm going to come back and do another video and actually try and build it. So thanks for watching, and bye.